So you don't need to write this down. We're starting section 2 for 10.5. Second day. It's a very short day, but we're going to try a couple of problems that involve completing the square in a real world problem. Now you could solve these things other ways. I mean, what is another method we've used for solving a quadratic equation? We graph it. We all love that, right? Everybody loves graphing. Yeah. Kind of takes a long time, so we try to avoid the graphing if we can. And what about taking the square root? If we simply have a quadratic equation that doesn't have the middle bx part, right? You can just isolate x squared and take the square root. That was another method. Another method was, it's an factoring, right? Easy to factor things, like we just saw in our warm-up. This one on the left, we actually could have just factored it. If you're at home, you didn't see the warm-up. But anyway, factoring is nice when it is factorable. When it's not factorable, today and yesterday we were using completing the square. So here was one not factorable. If you're at home, you can try it. And so we used completing the square. Today we're going to use it in some word problems. So look at this. You have decided to use chalkboard paint to create a chalkboard on a door, rectangular door. You want the chalkboard to have a uniform border. Uniform means the same, right? So each side is the same width here, from the outer edge of the door to the chalkboard. See that? Okay. And you have enough of this paint to cover 6 square feet. So find the width of the border to the nearest inch. That's nice, the nearest inch. So it's not hundredths or something. Okay? So they suggest with this type of a word problem to use a verbal model. We're trying to find this distance, but we don't know what it is, so it's some kind of unknown. They actually give it a variable and they call it x. Okay, so we need to find x, this distance. But what do we know? What do we know about the green chalkboard that's really helpful? It's a rectangle, number one, that's nice. And what is the area of that chalkboard? Area is 6 feet. We know it's going to be 6 feet. And 6 feet squared, right? And so we know the area of a rectangle is, give me the formula. Base times height. So all we have to do is figure out the base and height of this chalkboard. And it's kind of like a donut problem. We can take it out of this equation. Or maybe we'll just be able to find x that way. So let's look at this chalkboard like this. We have this distance here. Let's call that the base. And this distance, which is the height. Okay? So I don't know what it is, but you know this entire length is what? 3. So the base would be 3, but we've got to take away this piece and this piece, right? This much and this much, leaving us with what we really need. And what can we call these two pieces here? X, that's right. This is a distance of x. This is a distance of x. See that? So how many x's is that? 2. So this base here is really 3, take away 2 x's, right? Now, I'm sure having done that, you can all tell me what the height is. The entire door is 7, right? And what will we have to do to that? Subtract what? We have x down here and x up here, right? So subtract 2x, okay? And what were we being asked to find? X, right? And x is showing up in this equation. We have 6 equals this stuff. We can isolate the x and know what it is without doing anything else. Interesting. Okay, so what would you do at this point? Somebody said FOIL. Haley, you said FOIL? Good. Because this is not set equal to 0. We have to figure out how to get it equal to 0. So you're right, foiling it. So Haley, tell us what we have. Minus 6x minus what? So minus 6 and minus 14 is what? Minus 20x. And then negative 2x times negative 2x plus 4x squared. X times x is x squared. Okay? So this doesn't look the way we normally see it, right? This isn't in the kind of standard form we're used to seeing. So can somebody, should we subtract 6 first, or should we put it in standard form? What do you think? Standard form first? Okay, so John, tell us what that is.
4x, 6 equals 4x squared minus 20x plus 12.
Good. Okay, so now we're going to want to set it equal to 0, right? So how do we do that? Subtract 6. Good. And we have an equation equal to 0. Plus what? Okay. So, does this look like an easily factorable equation? Not really. I mean, we had that strategy of multiplying a times c, remember? We could multiply together a times c, and then factor it and see if we can have factors that add up to 20 or whatever. But let's use our completing the square. Okay? So, we're trying to create a perfect square trinomial. So what is the first thing we should do to this equation, Jenna? Before that, maybe. Divide by, why is that, Madeline? You want this to have a coefficient of 1 to simplify things, remember? So let's do that. Let's divide everything by 4. You're going to have a chance to do one of these in a minute, so you don't have to write this down. X squared minus 5x. Now this is kind of a nightmare. So let's just leave it as 15 over 4. Remember how we discovered that leaving it as a fraction can be easier? So if we wanted to, at any point we could change this to a decimal. Okay, so now what would we do, Jenna? Subtract 15 over 4. So this is going to look different than how we've been doing it, isn't it? If you want, we could say this whole equation equals 0 this way, right? And now we could move the 15 over 4 to the right, which is probably more comfortable since that's how you have been looking at these. So let's do that. X squared minus 5x equals negative 15 over 4. Okay? So notice I left space because with completing the square, we want to add the perfect squared term over here, which is not easy here. What is that term? What is half of 5 squared? Half of 5 squared is 5 over 2 squared is 25 over 4. Let's just call it that. We're going to add that to both sides. And because we left that in fraction form, we now have two terms that are easily combined, right? And so on the left, our perfect square trinomial, which is a bit tricky, can be called x, what? What's the sign? Minus. And then the square root of that, we're back up here, 5 over 2. Just call it that. Equals, what do we have left here? 10 over 4. Okay. So the next step is to do what? Take the square root. Okay, so we have x minus 5 over 2 equals you could leave this as the square root of 10 over what? 2. We can keep, because 4 is a perfect square, we can pull that factor out, and we can leave 10 there for a minute and see what it is equal to in a few moments, right? Because the final step is to add 5 halves to both sides, right? And when we do, we have x equals the square root. Do you want to estimate the square root of 10? What is the square root of 10? 3.1 over 2. Positive 3.1 over 2 plus 5 over 2. Or negative 3.1 over 2 plus 5 over 2. Plus or minus 3.1 over 2. Okay, so in this first case here, what is 5 plus 3? 8 over 2? 4. We're just rounding it now, okay? And what is negative 3? Let's call it negative 3 plus 5. So 2 over 2 is 1. So look at this. We have two possible solutions for x. So let's go back up to the door. Okay? One solution we got for x was 4, and one solution was 1, right? Is it possible that the border here could be 4, chalkboard, and 4, and still have a 3-foot wide door? No. So that ends up being an extraneous solution. Okay? 4 does not really work, so it's called extraneous. And so x equals 1. Okay? So I know it feels like a lot of work, but your choice is to graph it or to do this, math. So you may choose which you prefer. Okay, so here's one for you to try, and I will come around and check your work to make sure that it is correct. When everyone's done, I'll walk through it, okay? And what did you do at the top? What did you do?